We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
What role does energy storage play in shaping our energy systems? Today's episode is hosted by Dr. Nadine Moustafa, a research associate at Imperial College London, specialising in carbon management and decarbonisation technologies. Joining Nadine are Professor Martin Freer, CEO of the Faraday Institution. Martin brings a wealth of experience in energy storage with a distinguished career in pioneering research across nuclear energy, battery technologies and energy systems. And joining him is Jingyi Chen, Head of Battery at Breathe Battery Technologies. Jingyi specialises in cutting-edge battery management solutions, enhancing performance across automotive, consumer electronics and energy storage. In this episode, they explore the role of battery technology in achieving net zero and supporting sustainable energy goals, batteries in everyday applications, including home energy storage and electrical vehicles, and strategies to improve energy storage efficiency through innovation and sustainable practices.
Hello, I'm Nadine, and today I am here with two guests that will talk more about energy storage technologies and how they're going to be contributing to our net zero goals. And I'd just like to start with an introduction from both of them. So, Martin, would you like to go first?
Yeah, sure. So I'm Martin Freer. I'm Chief Exec of the Faraday Institution. Before that, so I've been in post since September. Before that, I was Director of the Birmingham Energy Institute, University of Birmingham, and also Director of an organisation called the Energy Research Accelerator.
Thank you for that. And Jeannie, would you like to introduce yourself?
So my name is Jingyi. I'm the Head of Battery at Breathe Battery Technologies. So we're working on battery management software to enable adaptive charging technologies on both electric vehicles and consumer electronic devices.
Thank you. And so I think our first question should be, how do you see energy storage technologies contributing to net zero goals? And I think, Jeannie, if you want to go first for that one.
Yeah. So I will perhaps see this from a renewable energy angles. The energy generation from renewable has a nature of intermittency in them. So those models, the energy storage systems needs to be enabled to capture those intermittent generations from, for example, wind and solar power. And the whole electrification needs to take into account those storage intensive models as it goes. So this is one of the considerations I always have in mind, that the renewable needs to be part of it, and our electricity that we use for our electric vehicles and other consumer electronic device needs to be from renewable sources as well.
Thank you for that, Jeannie. And so I think, Martin, would you like to add anything to that and maybe comment on the biggest challenges of integrating energy storage technologies into our existing infrastructure?
Yeah. So Jingyi is exactly right. So we face enormous challenge around integration of renewables into our grid. But if you take a step back and think about the transition that we're facing in terms of the move from a lot of technologies which are using AC to technologies which are DC based, so thinking about solar power and indeed battery storage technologies, we've got to find ways of integrating this into the grid. We're moving from a system which has been largely based around coal generation. We've got a large amount of gas, but the great news is that we've managed to remove the coal generation from the grid, and that is a big step forward. But as we make this transition, we're moving away from synchronous generation, and that is one of the things which stabilises the grid. And so we have two challenges. We have how do you bring energy storage into that grid system, and how do you manage a grid which is becoming more and more unstable in the sense that the traditional way that we have created that stability. And if you think about how we have used energy storage to date, it is so we do have hydro storage. So there's a large hydro plant in Wales, so that is one component. But most of what we do is using gas. And we got about 1,000 kilometres of the transmission grid. We've packed a stack of gas into that grid, and that is great for managing the interseasonal storage issues. As we go into the winter, we burn much more gas than in the summer for our heating. But also, if you look on a daily basis, you get spikes in generation. In generation, but also in utilisation. And it's managing those spikes that we do with gas. And so storage needs to think about how do you manage that short term all the way through to the long term. And that is a big challenge, how we transition the grid from where it is right now to where it needs to be by, 2030, 2035. It's not too far away.
Yeah. And I think just to follow up on your short-term versus long-term, I wanted to ask, how do you see, so I know this episode will actually focus more on batteries, and so I wanted to ask, how do you see batteries kind of fitting in with all the different energy storage technologies? So for example, you mentioned hydro, but also compressed air.
Oh yeah. So there's a lot of choice to make, and we should think, so although we've been talking there about electricity, we should remember that energy, and we heard that there's EVs and batteries, of course, sit in EVs, and that's part of the transition. But if we think about heat is about 3 times our electricity use in energy terms. So there's a huge amount that needs to be done there. So we need to think about storage not just in electrical terms, but we need to think about thermal storage as well. And that will mean what thermal stores people put into their homes. It also means what thermal stores you put into district heating systems, and how you have that interface between electricity and thermal energy. And so if we think about where different storage technologies will fit in, so batteries are brilliant for short-term storage, and the thing that makes them brilliant for short-term storage is that they have relatively fast discharge times and charge times, and they are very efficient. So they're about 80% efficient, round-trip efficiency. And that means that if you look at the price variation that you get on a daily basis, which might be a factor of 2 with 80% efficiency, if you're cycling your battery a few times a day, you can make quite a lot of money out of that and make a return on your capital investment associated with that battery technology. But batteries turn out to be quite expensive, and so that if you're not cycling your batteries very often, then you're not going to make very much money. In fact, you might make no money at all. And so at the moment, it looks like we need other technologies. You mentioned compressed air. There's a variety of compressed air type technologies, diabatic, adiabatic technologies. We can come back to them if we're interested. So those are bigger and potentially could be built at the grid scale. We have the hydro. We have potentially hydrogen, which could feed in as an energy storage vector. And we have technologies such as liquid air energy storage. And most of those are good candidates for longer duration energy storage.
Okay. And I think, given that we mentioned batteries, maybe Jingyi, you could give us a brief overview of what Breathe Batteries does?
So I think we have been looking in a more focused lens into what battery can do in different sectors, and energy storage is one of the critical ones that we have been looking into. So battery as an electrochemical device ultimately it's not very high in its energy density in comparison to other competing technology. But what's very advanced in the battery technology is it has years of experience accumulated in terms of how we mature and integrate this technology in the consumer electronics and EV market, that we can easily transfer those knowledge to energy storage. So in a sense, the technology is ready, and it's highly modular to easily scale in terms of how it has been designed. So I do think if we are looking into a more targeted application of short-term and distributed storage, battery is actually an ideal candidate to go for.
And it's worth adding that when we talk about batteries, there's lots of different types of batteries, isn't there? So at the moment we have lithium-ion technology, and there is a particular price point around that. And lithium-ion probably is serviceable for, in terms of grid storage, about 4 hours. So that, pushing it maybe 6 hours. But there are future generations of battery technology, so sodium-ion, which could allow longer, let's say 12 hours of competitive energy storage. And I think one of the big challenges that you asked about challenges, one of the big challenges that we have is finding ways to make batteries last longer and make them cheaper. And if you look at what's happened, the price curve for battery technology, it's come down dramatically. And I think there's great potential with the fabulous innovation that we have in this country to really push that technology out further.
And given that you're a startup or an SME, can you highlight a recent breakthrough maybe that Breathe Battery Technologies have done? Just to comment on what Martin was mentioning about innovation.
Yeah. So we certainly see a trend of improving the durability of a battery systems. I think probably if we look back before EV picked up, the battery typically are designed to last for 3 to 5 years, which kind of align with the device lifetime of a phone or a laptop. But we see the engineering efforts behind it, that we nowadays can see a battery system to last 10 to 15 years that's suitable for electric vehicle applications. I think generally there's a trend for people to optimize their engineering, both from very front end of materials and mechanical design of a battery systems to control and management, and ultimately to the whole system integration. So there's a lot of things going on in the battery field. And I certainly see that when we improve those engineering practices, it will be more relevant to the energy storage systems.
I think following up from that, so you mentioned the sustainability and the materials. I know it's something that people are talking about in all of the different industries and all the different technologies. We need all these minerals and materials if you need to build any kind of technology. And so with the growing concerns of the resource availability, can you comment, and then I'll move to Martin, on how you're envisioning that within Breathe Battery?
So certainly one of the biggest challenge with battery materials, it's very difficult to recycle and separate the materials when they reach end of life. I think one of the areas that Breathe focuses on is to extend the usage life of battery by adopting physics-based adaptive charging or management strategy. So we have been looking into sort of one layer deeper to understand the physics happening inside the electrochemical devices, and we utilize our state estimation to understand those internal states of battery. And based on those, we can design a more adaptive control strategy to prolong the cycle life of a battery. This has been quite a bit of collaboration going on, and actually 2 years ago, we published a co-marketing material with one of the China's biggest phone manufacturers, Oppo, where we extend their cycle lives from 1,200 cycles to 1,600 cycles. So this is one of the things that we can actually extract more values from a battery system by simply optimize the control and management, and let alone that there are other areas of optimization we can do on either the firmware on the material design side.
So focusing on basically extending the cycle efficiency of all the materials that you get by, making your batteries more efficient.
So I think on one end, we focus on extending the cycle life of battery when they are in usage. So to, in a way, help with the challenges with recycling and repurpose. And the other way is if we manage the system in a better way, so the battery actually end up in a healthier state when they retire, they're also more suitable to be repurposed for second life applications like energy storage.
Oh, okay. And Martin, do you want to comment on that and maybe challenges within recycling?
Yeah, and I was remiss not to say that the Faraday Institution has a whole bunch of projects and programs, and so there's 10 areas of research, and one of them is on recycling and reuse, and that's the ReLib program. This is such an important area as we're developing a new industrial technology, a new industry. We need to think about the consequences of that and sustainability, and that goes from all the way from the extraction of the minerals, and some stories to be told around the extraction of the lithium, which goes into the batteries, and the sustainability or lack of sustainability of that. Thinking about some of the critical elements which go into the cathodes of the batteries, so cobalt, manganese. So these are all elements that one needs to think about the sustainability of those. So there's two sides, isn't there? There's the design of the battery and the elements that go into it. There is the lifetime of the battery and making sure that we're designing things which last. But then it's also how you design recycling processes which can take those resources, because we don't want to lose those resources. It's a huge amount of effort and money tied up in that. But you need a way which is efficient in recycling and cost competitive. So it's got to be cost competitive with mining those minerals in the first place. And then the other bit is regulation. And I am sure that regulation is going to kick in here, and that with the battery passport that the European Union is looking at, there will be a certain fraction of elements that need to go back into the battery production process from recycling. So there's all sorts of bits that one needs to look at in order to get this right. And so companies like Breathe doing their bit is really, really important, but this has got to be an industry-wide government-supported programme.
I think I'll get back to other stakeholders, but just before we go there, I wanted to ask about innovations in the field. So how do you see next-gen batteries or solid-state batteries? There's a lot of talk about this. What do you think about this? Maybe, Jingyi, do you want to go first?
Yeah. So I think I generally see the next-gen battery materials as an opportunity for battery management system and control software that we have been working on. So essentially, if we look at lithium-ion battery, sodium-ion battery, solid-state battery, fundamentally in a sense, they share a lot of similarities in between the electrochemical reactions happening inside them. So they all comprise of a positive electrode, a negative electrode, and the electrolyte, and ions serving as charge carriers shuffle in between the electrodes to release energy when they are discharged or store energy when they are charged. So fundamentally, if we look into the physics of what's happening inside those different batteries, there are a lot of learning that we can share from the lithium-ion battery research to other new generation materials. And there are also some learning about how do we prevent or mitigate side reactions that we can learn from the lithium-ion battery understanding instead of starting from ground zero. So I definitely see this as an opportunity to accelerate the adoption of sort of physics-based control strategies in the new batteries as the sort of materials and design sector improve their ends of products. We can also come in as in to pull out the synergy between software-based control to what has been improved in the materials side.
Okay, and Martin, are there specific things the Faraday Institution are looking into in terms of research areas within the next-gen battery technologies?
Yeah, you wouldn't be surprised. Solid state, of course. So we got a project called SolBat, which is an intensive program to develop those solid state batteries. And some of these are already emerging through into market. So there are automotive companies who are taking solid state batteries and deploying them. This is early stages, but we're seeing these new technologies come through to market. We have another program called LiSTAR, which is lithium sulfur, so another technology. We have a big program around development of sodium-ion batteries, recognising that the opportunity that they have for the future. But there are some emerging areas which. So we have two, let's call them challenge areas, transformative activities, and one is to target very high energy density. So. Our present generation of technology is great for vehicles, but batteries can do so much more. You could think about electric flight, for example. There is a big frontier to be pushed there. And if you can manage to get the energy density up inside the battery technology, you open up that industrial area. And then the other frontier is the long duration energy storage. So making very low cost batteries which are competitive with compressed air energy storage, maybe competitive with hydrogen storage at grid scale in caverns. So looking at not just next generation technologies, but let's call them next generation technologies. So, as I said before, we've got some really talented scientists in this country, and that's what we are going to be pushing them to do in the next few years.
And I think, given that we're talking about scientists and skills, and there's a lot of talk about this, like the skills that we're going to need to reach net zero, essentially the skills that we're going to need for all the different decarbonisation technologies and the different pathways that we're going to go through. And given your experience in education and research, what skills or expertise do you think will be most critical for the next generation of energy professionals?
Yeah, and it's really challenging because if you look at the sector, it's a huge sector, where to put the boundary, but let's call it clean tech. It's a few $100 billion sector in this country, so it's a very big part of the economy, and it's growing fairly rapidly. So it's about 5-6% growth. So compared to other sectors, that is astonishing, and that growth means that there's a huge amount of demand for talent, and that doesn't just occur in the battery sector. That is everything from wind to grid infrastructure. So we're going through a major program of upgrading our grid infrastructure, and that's everything from the wires to the transformers, all the way down to the local grid infrastructure. Every sector is competing for talent, and every company is complaining that they can't get access to talent. And that is a big problem. And unless you can feed the talent pipeline, it doesn't matter how much money you've got to invest in projects and programs, unless you've got people to deliver it, it's not going to happen. And so, the kinds of people and skills you need are across the piece. So you need PhD students and graduates from those kinds of programs, all the way down to apprentices. And the Skills England programme, which is just going through Parliament, is probably a really important component. But in batteries, I don't know what you think, but in batteries, there seems to be a shortage of people coming out of university with a strong understanding of electrochemistry. Electrochemistry was a really important discipline, but has tailed away, a bit like everything. But the battery sector, new things come up and grab the curriculum. But the battery sector needs well-trained graduates out of universities, I would say.
I probably want to add on a bit on that. So perhaps in the past few years and also in the future 5 years, I would like to say this industries is experience ever increasing change. For example, 3 years ago, when I was in sort of first stepping into the electric vehicle conferences, people were talking about range anxiety and battery safeties. And as the consumer base became more and more educated, the topic of discussion shift towards or extended into more advanced topics like cost effectiveness, energy efficiency, and sustainability. So the customers are also getting more and more aware of what they are buying and demand more performance from the systems they have been paying for. So I think in this industry, change is the constant for the next few years. And for our talent pool, we have to recognize that people's skills needs to be upgraded. We need to have sort of new skills into the brought into the country to enable to accelerate the adoption of the technologies.
I think you're making this very easy for me, because my next question was actually going to be about consumers. So how do you see the role of consumer awareness playing in accelerating the adoption of battery?
So I generally see a positive feedback loop between the consumers and the OEMs, who we have been working very closely with. So the OEMs are trying to educate the consumer more about the values that they can get with introduction of new technologies. For example, you can have more energy density, you can have faster charging speed with certain technology integrating into the systems, and that perhaps go into the price label of the new products. But as the consumer become more and more aware of the benefit that they're getting, they also tend to support incentive for those new technology introduction and advocate for those. So this has become a positive feedback loop for this industry to develop and mature amongst those changes out there.
That's good to hear. And I think if we can, Martin, for instance, you've had a career in nuclear energy and now energy storage, and I kind of just wanted to ask, how do you see those two areas complementing each other?
Yeah, and I think that's the right framing, complement, rather than how do they compete against each other. And if we just stick with the nuclear side for a while, the nuclear has been on quite a bit of a journey as well, and has had to go through that journey of developing and establishing consumer public confidence in the technology. I think the world is a very different, UK world is a very different place now than it was back in the 1970s and 1980s, before your time, where there were demonstrations around nuclear power and a lot of nervousness. I don't think that exists now. But to go to where these technologies will fit in the energy mix, I think. The government has set us on a path of 24 gigawatts of nuclear generation, and we're down at a couple of gigawatts at the moment. So that is quite a big investment program, and that will be not just big nuclear power stations, but what are called small modular reactors, small nuclear power stations, and even it's quite an interesting journey. We're on the journey to build a fusion power plant in the UK, which is in itself a fabulous initiative. The thing that, if one was to think about storage and where that sits alongside nuclear power, one of the challenges nuclear has is that it's baseload. It generates most effectively constant electrical output. And that means nuclear power can't take advantage of market signals, market pricing. Now, if you were to put an energy storage plant next to a nuclear plant, then what you can do is store the electricity from that nuclear power plant when the price is low, and you could sell when the price is high. So you could get much more value as an operator out of your nuclear power plant. So I think that's not going to happen around gigawatt. The Hinkley Point C is not going to have a bunch of batteries connected to it. But these small modular reactors, that could be a really interesting development for the future.
And I think another technology that I know the Birmingham Energy Institute works on is, for instance, looking into hydrogen.
Yeah.
And so I also wanted to ask, how do you envision the roles kind of evolving within the energy storage field?
Yeah, and I don't think anybody knows the answer to that question, so it's a safe one to answer. So I can speculate with complete freedom. I mean, with hydrogen, we've been, again, through a bit of a journey, which is hydrogen is the solution to everything, isn't it? It can decarbonise your heating, it can decarbonise transport, it can decarbonise electricity, and can do grid-scale energy storage. It can decarbonise industry, all sorts of things. And I think we've got to the point now where we know it's not going to do everything, and we can focus down on the things that it might do. And where it's been argued that it has a significant role to play outside that decarbonisation of industrial processes, and outside perhaps decarbonisation of heavy transport, so trains and trucks and stuff, is in capturing waste energy. So we, from offshore wind generation, we waste about 4% of that a year, and 4% is about 1 in 25, isn't it? So that is... And we've got about 28 million homes in the UK. So that's about 1 million homes that electricity could have fed for a whole year, and we've wasted it. And those who are proponents of hydrogen would argue that actually you could have taken that electricity, put it through an electrolyser, and generated hydrogen, and then used that hydrogen when you need it at some time later. So it's a great idea. Whether it's scalable, practical, and realisable, who knows? But that is one big area to explore for the future.
I think speaking about scalable, if we just kind of fast forward to 2050, what role do you see energy storage playing in our daily lives and the broader energy system? And that question's to both of you. So maybe, Martin, if you want to go ahead.
So I think, and a lot of the discussion that one might have around energy storage is large-scale storage, but the kinds of storage that Breathe works on is small scale, isn't it? It sits in a car, and I think we need to equally think about what happens at storage at the small scale and what happens at the grid scale. And we need to solve both of those. And just to speak to the small scale, so if you think about your home, don't know if you've got a heat pump yet. No, all right, something for the future. You've probably not got an electric vehicle yet either, but if you brought those two things together, and with some solar generation, you actually have the ability to run a smart energy system. You've got a 50 to 100 kilowatt hour battery sitting outside your house. You've got a heat pump which is consuming electricity. You've got a thermal store inside your home, and that thermal store can store thermal energy. It means the heat pump doesn't need to operate all of the time. You can optimize then when you're charging your car, when you're running your heat pump. And actually those kinds of systems could save you an enormous amount of energy or electricity, and reduce your costs. So that smartness around that local scale, that domestic scale, is going to be really, really important, integrated into what we can do smartly at the grid scale.
And Jingyi, do you want to add to that?
Yeah, I think perhaps in my shoes as a typical consumer and a firm believer in green technology, I would like to see the future when all of our electricity is generated from 100% renewables. And of course, the energy storage will be a key enabler for this to happen. On the other end, as an engineer, what I would like to see is in the future that battery has an integrated sort of life cycle from transport to energy storage, because I think these are the two markets where the volume will be quite big. And if we can connect those two sectors very efficiently and optimize them as a whole, it will be a great achievement for us working on the engineering practices. So especially when we have second life batteries from vehicles, when they retire from the vehicle application, they typically retain 80% capacity, which means they can still store a lot of energy and are very much usable for less demanding environments. For example, like stationary storage systems. And these are the fields that we haven't really optimized yet today, and there are a lot of effort going into optimizing this. So I generally see great synergy on sharing those common knowledge we have learned from these sectors in both design and control strategy. And I see this as a future of a better engineering practices as a whole.
I think just to follow up on that, and maybe my final question, how important do you see is cross-sector collaboration, and not just within industry, but also looking into academia and policy? I know Martin kind of mentioned policy and regulation.
I see this as a key pathway we have to go through. So the whole different sectors should share a clear visions and clear mechanisms of responsibility sharing. So for example, the academias are in the forefront of developing new technologies. So to provide means to reduce costs and optimize efficiency. But on the other end, the government needs to target fundings, tax incentive, and subsidies in the right way to enable the uptake of those new technology coming out of academia. And later on, the industry has to have a better system of regulation to ensure consistency in the long term when we integrate those technologies at scale. So this has to be a collaborative effort, and everyone has a very critical part to play in it.
And Martin, given your roles in both industry and academia, what do you see going right and what do you see going wrong? What do we need to fix, and what's the role of government here?
Yeah, well, I agree. All of the above. So collaboration is extraordinarily important. I was just reading the Long Duration Energy Storage Council's report 2024. They I think come up with a number which is about 8 terawatts of storage which is required, and that they've done an assessment which indicates we need to go about 50 times faster than we are at the moment. And so what that tells you is that so industry can't deliver this alone, academia can't deliver it, and government has a really big role to play in this space in incentivizing and catalyzing. In the battery space, through the Faraday Battery Challenge, they've already put in considerable amounts of money into storage technologies, and that is the thing which funds the FI, the Faraday Institution, and also the UK Battery Industrialisation Centre and all sorts of other things. And that is working very closely with the automotive sector. If one looks at what government's done so far, they put about 70 million into energy storage programs, and that would be flow batteries, that would be pumped thermal energy storage, it would be compressed air storage. So these are kind of beginnings of the journey programs. 70 million is not going to deliver us a revolution, is it? So it needs a lot more than that. And as you were saying, it needs the right market incentives. So the government has just consulted on what the market mechanism is, something called a cap and floor. So a maximum price that they will pay for energy storage, a minimum price that they'll pay for energy storage. So that is the beginnings of the kind of relationship that is needed. But this is such a big challenge, and it needs to happen so quickly that we need all three sectors to be working really closely together in a mission-driven approach.
I think with that, the conclusion is that we really need to work all together, academia, industry, and policy and governments. Thank you both for the amazing discussion. And I just wanted to ask if people wanted to know more about your work, where should we send them?
So in my case, the website is a good place to start. So get it right. The Faraday Institution website, just Google it. You'll find all of the great things that we're doing and contact details there.
Perfect. And Jingyi?
Yep. So in the same way, we have a website. If you search Breeze Battery Technologies, it will bring you to there. We advertise also the recent product breakthrough and our collaboration this year with Volvo Cars as well, where we enable software-defined batteries to their next generation fast charging. I feel this will be an interesting piece to start reading.
Thank you both again, and thanks everyone for listening.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.